So this is week 4 of Math 242, and we'll look at data analysis and statistics, and this will be a two-part. The first part will be with week 4, and the second part will be with week 5. So when we look at the big ideas, we're going to start with grade 1, and we'll move to grade 6, and we'll look at different ways that we can organize data and different ways to represent the data in different graphs, whether that's bar graphs, histograms, line plots, and box and whisker plots. So we'll look at the first one. We can see that we're looking at grade 1, measurement and data. And so this is one where students are looking at just who represented what opinion on favorite color. And then we're just representing how many reds that we see. And we see 6 reds. And we see 2 greens. And we see 5 blue. So how many people chose red as their favorite color? We would say 6. How many people chose blue? We would say 5. How many people chose green? We would say 2. What color received the least amount of votes? Well, that would be green. And then it asks to write a number sentence that would tell the total number. So the students are working on writing a number sentence to represent the total. So that's something that they would see in their measurement and data for first grade. Another type of looking problem here, you've got Science Museum, Art Museum, History Museum, and they voted on their favorite place. So we're kind of using a pictograph in a way to represent how many students fall into certain categories. So we see that we've got 6 students that like the Science Museum, 8 that like the art, and 6 that like history. So how many students chose art museums? And that would be 8 students. How many students chose art or science? So this or is just representing the sum when we say art or science. So we get to add those together. And then from this data, can you tell how many students are in this class? Well, we would do a sum of this number sentence, so 6 plus 8 plus 6. And we would get 14 plus 6, so we would see there's 20 total students in the class. Here we've got more of a vertical type of pictograph. So here we're looking at lunches, and we know what everything represents. What the icons represent is 1 student. So we would see that 7 students here, 6 students, and 4 students. How many more hot lunches orders are there than the sandwich orders? So we're just saying how many more, that there's just 1 more. You can find that by finding the difference. How many fewer salad orders are there than hot lunch orders? Well, that would be 7 minus 4, because we're seeing how many fewer salad, so that difference would be 3. And then if 5 more students ordered hot lunches, so we're saying if 5 more ordered here, then we would see we would have 12 total hot lunches. So jumping to second grade, looking at measurement and data type of problem is counting and organizing. So we're going to take how many have no legs in these pictures. And we would say that the snake would have, there would be 1. How many with 2 legs? So we would have, looks like we would have 3. And then the 4 legs, 1, 2, 3, that would have 4 legs. So we can, we can write the number in. We could also use tally marks. So with the no legs, we could put the 1 tally mark. With the 2 legs, we could do 2 tally marks, and the 4 legs we could, or 3 tally marks, and the 4 legs we could use the tally mark. And then of course we would discuss with students that when we get to 3, we get to 4, the conventional way to do that is to slash through to represent 5. Here we're looking at our vertical bar graph because our title of this is Central Park Zoo. And then we have 1 block would equal 1 animal. So here we would say we're going to have birds, and we're going to have fish, and mammals, and reptiles. So you can have students label their graph vertically. And then it's just a color in at this point. With birds, we see that there's 6. And then with fish, we see there's 5. You also could call this is your frequency along the left side as well. How many mammals? Well, we have 11. All the way max up to 11, and then all the way down. So we see our spaces between our vertical bars. And then our reptiles, we have 3. So how many more animals are mammals than fish? So we're looking at the mammals of 11 and the fish of 5, and we would see that there's 6 more mammals than fish. How many more animals are mammals and fish? Well, mammals and fish would be 11 plus 5, which would be 16. And birds and reptiles would be 6 plus 3, which is 9. And that question says, how many more animals are there, are mammals and fish than birds and reptiles? Well, that would be a difference of 7. How many fewer animals are reptiles than mammals? Well, we see we've got 11 reptiles, or excuse me, 11 mammals. We've got 3 reptiles, so we would see we would have 8. And then with part D, it's one of these types of problems that it kind of opens it up for the kids to allow them to ask a question and them to develop an answer based on the information. So they could say, well, how many fish need to be added to equal mammals? Well, if there's 11 mammals and there's 5 fish, then we would need to add 6 more fish to be mammals. So a question like that could be created. Another type is we've got dimes donated. And so we got Kylie and Tom and John and Shannon. And so that's what we'll do is we'll say, here's Kylie, Tom, John, and Shannon. And Kylie donated 12. So we've already got it labeled. There's Kylie. And Tom donated 10. And John donated 15, so the maximum on this graph. And then Shannon was 13. So again, you see the vertical bars. And then we see our totals, and the totals are actually from the table, so we're just taking it from the table to a graphical representation. So how many dimes did Shannon donate? 13. How many fewer dimes did Kyle donate than John and Shannon? Well, John and Shannon were both 28 together. So we look at John and Shannon together had 15 plus 13, which was 28. Now, how many fewer dimes did Kylie donate than John and Shannon? Well, if you look at John and Shannon total, Kylie was 12. You could say 16 less than John and Shannon. D, how many more dimes are needed for Tom to donate the same as Shannon and Kylie? Well, Shannon and Kylie is 13 and 12, so that's 25. And how many more dimes? Tom already has 10. How many more does he need to get or add to get to 25? And that would be 15. And then you can ask, well, how many dimes were donated in total? So there's where you're looking at adding up everything together. And 20, 30, there's 40 and 10. So 50 total dimes donated. So grade 3, we're looking at a table. A number of students in each class. You got a baking class, a sports class, a chorus, a drama. You got the number of students. And notice that we already got you started on baking, where you can have some, where when you look at your intervals aren't always the same. Here we've got intervals of 2. So each block is representing 2 students. And that's what it says up here is what's the value of each square? Well, that would be 2 students. Write a number sentence to find how many total students are enrolled in the class. Well, that would be 9 plus 16 plus 13 plus 18 to equal the total. How many fewer students are in sports than in chorus and baking combined? Well, chorus and baking combined would be 13 plus 9, which would be 22. And then sports, you've got 16. So you're looking at how many fewer, and that would be 6 students. And then you can write a number sentence to show that. And you could show 22 is equal to 13 plus 9. You could also show that 22 minus 16 is equal to 6. So you're just showing your work, your thinking in that type of problem. Here is where we're asking to do a line plot based on, here's a horizontal number line. And we see that use the graph line ruler to draw in the intervals on the number line. So we know that we're going from 0 to 70. So we would look at intervals of 10. And then we could say, well, Friday has 25. So Friday's going to be somewhere here. And then Thursday has 50. So there's Thursday. And then Wednesday is 55. So Wednesday is going to be somewhere there. And then Tuesday is going to be the same as Thursday. And then Monday is going to be the same as Thursday. So you got Monday, Tuesday, and Thursday all on the same. Don't have a lot of room there, but that could be something where on 50, you could show Monday, Tuesday, and Thursday all on the same. And then you could ask, well, which days did Charlotte read the same number of minutes? And that would be on Monday, Tuesday, and Thursday were all the same. How many minutes did Charlotte read on these days? And you can see from the line plot that it was 50 minutes. How many more minutes did Charlotte read on Wednesday than on Friday? Well, Wednesday was 55 minutes, and Friday was 25 minutes. So how many more how many more from 25? So we would see that she read 30 more on Wednesday than on Friday. Lots of good questions you can ask from your graphs. Here's your third grade. So just kind of a different way. Everything is given in your data set here. So now it's just creating a line plot based on our numbers. So here I've got 48, and I'm going to go to 49, and I'm going to go to 50, and I'm looking at all these values in between. I've got everything divided into fourths. 1/4, 2/4, 3/4. The 4/4 would be 49, and then the 1/4, 2/4, the 3/4, and then the 4/4 to get to 50. So now what you're doing is you're figuring out each of these 48 3/4, 49 1/2, 49 1/4. So what you're going to do is plot everything that you see. I'm just going to plot this in a different color. So there is a 48, and there's two 48 1/4. There's no 48 1/2. There's three 48 3/4. So here's your half. I'm sorry, there's your fourth. There's your half. There's your 3/4. There's your fourth. There's your half. There's your 3/4. And so you are kind of talking and discussing about fractional increments within not just from 48 to 49, but from 49 to 50, but also the student seeing that the fractional interval repeats. Then you're just placing dots wherever you see. And you try to line these up as best you can. 49, there was 5 of them. And 49 1/4, there was 3 of them. 49 1/2, there was 2 of them. 49 3/4, there was 3 of them. And 50, there was 1 of them. So you can kind of see, just not that you're looking at these types of graphs, but in third grade, but you can kind of see how the graph would flow. So then you're just having students explain the steps that it takes to create the line plot. So what you would want to do is draw that line. As I did, I drew a horizontal line, and then I drew 3 tick marks. And I drew those tick marks here at 48, 49, and 50. And then I drew quarter marks between 48 and 49 and 49 and 50 to create 4 sections. And then finally, I just drew the dots to represent the frequency in each position. And you just draw them vertically over the specific number. So you could say, well, how many marshmallows traveled from 48 3/4 inches to 48 how many traveled 48 3/4 inches, then the 48 1/4. So you're looking back at the 48 and 3/4. So we see we've got three that traveled 48 and 3/4, and you got two that traveled 48 and 1/4. So we only had one marshmallow that traveled more than the 48 and 1/4. So the 48 to 3/4, 48 to 1/4, there was only one more. You can also ask, all right, well, find the three most frequent measurements of the line plot. And it looks like 48 and 3/4 and 49 and 1/4, 49 and 3/4. '49 also had a large amount. So you're looking at kind of where are the frequent. So here's 3 and 3 and 3 and then 4. So you can start to discuss where certain numbers fall and the frequency and how many times you see it. All right, jump into 4th grade. We start to see that the increments still are we see fractional measurements. And here, this chart below shows distance 4th graders in Mrs. Smith's class were able to run before stopping for a rest. So we're just going to create a line plot to represent that. So remember, you draw your line. And looking at all of our numbers, I see 2, 1, 2, 1, 2, 2, 2, 5/8, 2, and 2. So we can make our units go from 0 to 1 to 2 to 3. So that should get everything. And since we see halves, fourths, and eighths, we're just going to make everything out of eighths. So 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and then our whole. And then we'll just do that over again. So 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8. There's another whole. 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and another whole. So again, we're just going to continue with the line plots, and where I would want to see 5/8. So there's Jenny at 5/8. So 1, 2, 3, 4, 5/8 would put her right there. And then we see we've got 1 and 5/8, and then 1 and 3/4, or 6/8. And then we've got 2 and an 1/8, and then 2 and 2/8, which is 1/4. So 2 and 1/4. And then we've got 3 at 2 1/2. And then we've got 2 and 5/8. And that should be it. So there's 3, 4, 5, 6, 7, 8, 9, 10. And we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we should see 10 on our graph. And this would be your line plot. And then we can just answer questions accordingly. So we're kind of jumping back and forth here. So who ran a mile farther than Jenny? Well, find out that Jenny was 5/8, so Jenny is right here. So 5/8, a mile farther would be Morgan, which would be 1 and 5/8. And who ran a mile less than Jack? Well, Jack is at 2 and 5/8. So Jack's here. So who ran a mile less? Well, that would also be Morgan. So Morgan seems to be right in the middle of Jenny and Jack. there's 2 students that ran exactly 2 1/4 miles. Identify those. Well, that would be Madeline and Anson. Madeline was 2 1/4. Anson was 2 2/8, which is also 2 1/4. And then we could say, well, how many quarter miles did each student run? Well, then you're starting to look at, for instance, Joe. Okay. Well, Joe ran 2 full miles, so that would be 8 quarter miles plus a half, which is 2 more quarter miles, so that would be 10 quarter miles. Bobby ran 8 1/2 quarter miles. Jack would run 10 1/2 quarter miles. And Tyler would run 10 quarter miles, same as Joe. And then Aaron ran 9 quarter miles. Ariana with 7 quarter miles. Morgan with 6 1/2 quarter miles. Madeline with 9, so that means Ariana and Madeline both had the or Anson, Madeline and Anson both had the same number of quarter miles. And then Jenny with 2 1/2 quarter miles, and then Chandra with 10. So we can look at Chandra had 2 4/8, Joe had 2 1/2. Those are both the same. So we're also looking at equivalent fractions. And then we're looking at quarters. Even though we split up our line plot into eighths, we're also thinking about how many quarters would represent one whole as well. So one other question is, what is the difference in miles between the longest and the shortest distance? Well, the longest was 2 5/8, and the shortest was 5/8. So we would say that it was a 2 mile difference. Another question we could say is, let's compare the distances between Ariana and Morgan. Well, Ariana was 1 3/4, and Morgan was 1 5/8. So with that comparison is that beginning stages of, well, I need equivalent fractions. So I don't want to compare fourths and eighths. Why don't we look at everything into eighths? And so this would be 1 6/8, and this would be 1 5/8. And then we could use our symbols to represent. And we would say that Ariana had 1 6/8, so it was 1/8 larger than Morgan. We could say that Ms. Smith ran twice as far as Jenny. So she ran twice as far as Jenny. So now we're looking at, well, 2 groups of 5/8 is the same as 10/8. And that would be the same for 8/8 plus 2/8, which would be 1 2/8, or 1 1/4. Now, Mr. Reynolds ran 1 3/10 miles. Compare that with Mrs. Smith. Well, down here we'll say, well, here's Mr. Reynolds at 1 3/10, and Mrs. Smith at 1 1/4. And here we've got a denominator of tenths, and here we've got a denominator of fourths. If we need to, we could take this to 20ths, So this could be 1 and 6/20ths, and this could be 1 and 5/20ths. So we are trying to get to equivalent fractions, and so we would say that Mr. Reynolds we would use the greater than symbol in regard to the comparison of those fractions. Looking in 5th grade, we're going to do another line plot, and with our dots, and then, but we also want to use with 1/8 inches. So we want to create, based on the location and the rainfall amount, we're going to look at this being 0, and then 1/8, 2/8, 3/8. There's your 1/2. And I might have to make this a little bit longer here. So again, we'll start with 0. And we look at our table up here, we've got 1/8, we go all the way to 1/4. So, or 1 and 1/4. So I'm going to go to 2, and then make everything with 8s in between. Okay. And then we would plot, okay, well, I see 1, 1, 2, 3/8. So there's my 3/8 there that I should see. And then I should see 2 at 1/4. And I should see 3/8. 1 at 3/8. And then 1 at 3/4. And then I should see 1, and then the 1 and 1/4. So these line plot using dots to represent your frequency, how many times you see it, so which location received the most rainfall. And we would say location 6. At 1 and 1/4 inches, which location received the least, and we would say location 1 and location 7 and 10. They all had 1/8. What we see that was the most frequent, we saw that that was 1/8 inch. And what was the total rainfall in inches? Well, now we're just adding up everything. So we saw that we had 3 1/8 inches plus 2 and 1/4. We had 2 1/4. We had 3/8. We had 2 3/4. And we had a 1, and we had a 1 and a 4th. So this will be 3/8 and 2/4 and another 3/8. And this would be 6/4 plus 2 and a 4th. And we could just make everything 8s here, so we would have 3/8 and 4/8 and another 3/8, and then that would be 12/8, and then this would be 2 and 2/8. So to find that total, we would just add up all of the numerators, 3, 4, 3, 12, and 3. And so that should give us 24/8 plus the 2 wholes that we already had, Well, 24/8 is actually 3 holes plus the 2, so we should have 5 inches of rain with everything total. All right, so that's going to lead us out of 5th grade. So we've looked at grades 1 through 5, and this is where we'll end up with grade 6. And we want to start with statistical questions. And so when we're talking about statistics and using data to answer questions, a good statistical question can be answered by collecting data where you want to see variability. And of course, it's got to come from a certain population, and it needs to be a clear question. But a very good statistical question is right here in that idea that it creates variability, more than one answer. So looking at some examples here. So we want to determine which question could be a good statistical question. How many letters are in my last name? Well, we go with, if everybody's thinking Wilson, then there's only one answer to that. So there's only 6 letters. And so there is no more answer. There's not any other answers besides 6. So this one is not a good statistical question. Now, how many letters are in the last names of the students in my 6th grade class? So if I've got, maybe I have rotating classes. Maybe I have 4 classes of 20 kids in each, or maybe I have 5 classes of 20. Now I've got 100 kids, and how many letters are in the last names of the students? Now we've created quite a bit of variability. Could have short last names, longer last names. So what you're going to create is all this range of numbers. So notice that last names of students in my class. Now we're looking at variability. What's the maximum number of feet that roller coasters drop during a ride? Well, the maximum number could change. It depends what roller coaster you're talking about. And so all of those are going to have different level drops. It's going to create different answers. Looking at D, what are the heart rates of students in my 6th grade class? Well, many of them will have different heart rates. So that will create more than one answer. E, how many hours of sleep per night do 6th graders usually get when they have school the next day? That could vary. And it would vary. You could even take 6th graders out and then look at high school students, or you could, thinking maybe of teachers and students in the school, even ask adults or whatnot, something that's going to question that is going to create that variability. How many miles per gallon do compact cars get? Well, that's going to vary. What's my favorite color? No, because I have one favorite color, and that's not going to create any variability. How old is my math professor for our class? Well, not that old. However, there is one answer, so that would also be not a very good statistical question. Frequency tables is another standard for statistics and probability. So a 6th grader rolls 2 number cubes but rolls them 21 times, and then the student looked at the sums. Okay, so if we see here, we've got the following sums that showed up. And so we could say, well, I saw there was a 2 that happened one time, and there was no 3s. So I'm just going to put a dash. So we would say the frequency was 1. And then how many 4s? Well, there was 1, 2 4s. And so that was a frequency of 2. 5, we had 3 5s. So that's a frequency of 3. What about 6? Well, we had 4. So that frequency of 4. 7s, we had 5. 8s, we had 3. 9s, we saw that we had 2. 10, we saw that there was no 10s. So that was a frequency of 0, frequency of 0. And then 11s, we saw there was 1 11. And then 12s, there were no 12s, so it was a frequency of 0. So we could ask what sum describes the center of the data. So we could say that 7 would describe the center of the data when you're rolling 2 number cubes 21 times, and we see how many times we see right here 5, just from our frequency. That was the one that showed up most, and it was a 7. What sum occurred the most often for, of course, was 7. Why is this? What are different ways to look at the outcomes? Well, if you look at all your possible, you've got if you're looking at 2 number cubes, so when you take 2 number cubes, this is what we call our sample space. So we've got 36 possible. Well, if we look at the sum of 7 are going to fall right here. And so you actually have 6 out of 36, which is 1/6, and that's going to be your largest ratio, and it's going to give you your best chance. So that sum of 7 is going to show up the most often, even in your, so in the theoretical probability out of 36 possible, we should see 6 out of 36, which will be the highest number and the highest sum. So that's kind of a way to prove that as well. Then we can look at histograms and relative frequency. Histogram's a little different than your bar graph. It does describe the distribution, and it will show center and variability. We can look at relative frequency histogram using the relative frequencies, and we'll create that chart in just a moment. But to make a histogram, here's kind of your idea process. You're going to draw that horizontal line. You're going to make intervals, and that's what sets an histogram apart from a bar graph, is your intervals along your horizontal. Typically, it's your horizontal axis. When you're showing a histogram, you can rotate that and make that a horizontal axis, or on your vertical axis, and that's typically when you rotate a stem and leaf graph. But this is your typical way to create a histogram. And so you can refer back to the notes here on how to create that. So if you're given values, so this would be intervals of head circumferences for cap sizes. You've got extra small, small, medium, large, extra large, and double extra large. And you can see the range of circumference measured in millimeters. And then how many show up. And that number that you see here, you're going to show here in a frequency number. Just one was in a tally format and the other one's in numerical format. And then we just figure out, well, that's 2 out of 40. So 40, if you'll notice, 40 is from your total. And 2 out of 40, you create a relative frequency number. And that can be listed along the vertical axis. And so you just think about your increments that you would need to make to incorporate all those relative frequencies. And that relative frequency is a probability. It's a desired outcome out of a total, or that success rate out of a total. And then you can show, based on this table, this data table here, can be transformed into a histogram that looks like this. So you can see the ranges of your head circumference. Notice the bars are all tight. There's no gaps. If there are gaps, that means that you wouldn't have any values in that range. If you remember back, if you have to watch the video again, you can rewind that to see that the bar graphs did have spaces in between because it's categorical data. This is numerical data, and because of the intervals that are placed, 510 to 530, 530 to 550, 550 to 570. So those are intervals. And then you see, well, where are these coming from? Well, those are your relative frequencies based off of the table that you would have filled out here. All right, so let's look at one where we can create tally marks. We'll create the frequencies. And we won't do a relative frequency just yet, but we'll look at creating a histogram. So here we've got a number of carbohydrates in a range format. And we would say based on our data up here, we would say we have one that falls in that 20 to 25, 2 in that 25 to 30. We've got 4. So over here I can write 1, 2, 4. 35 to 40, I don't see any, so we would have 0. 40 to 45 looks like we have 6. And then 45 to 50 looks like 4. And 50 to 55 looks like 2. 55 to 60 doesn't look like we have any, so that would be a 0. 60 to 65 doesn't represent any. And then 65 to 70, we have 1. So to create that histogram, we're going to draw a horizontal line and a vertical line. And we're just going to, I am going to break the graph just a little bit and start at 20 and just do increments of 5. So 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70. And then just extend my line just a little bit. And then here we're going to go from 1, 2, 3, 4, 5, all the way to 6. And then we just go ahead and we draw our heights of what we see. So from that 20 to 25, we saw we had 1. 25 to 30, we had 2 of them. 30 to 35, we had 4. 35 to 40, we didn't have any, so we shouldn't see a bar there. 40 to 45, we saw 6. 45 to 50, we saw 4. 50 to 55, we saw 2. 55 to 60, we didn't see any. 60 to 65, we didn't see any, but 65 to 70, we saw 1. So and this would be your histogram. And we can see that that center is somewhere kind of around in here. Center of that data set would be represented there. So next we'll look at one where we can create a relative frequency histogram. And so what we need to do is figure out, okay, well, we know how many are in the different range values. So I just need to tally up how many are in how many frequency, how many are we talking about? So when you add all those up, you're going to get 28. So that means that every number will be divided by 28. So 1 divided by 28. And so you're going to get 35 thousandths. So these are your decimal values that you would see. So we should see these values highlighted for each row. And we should see 7 values. Okay, so that just means that all we're going to do with these numbers right here is we're going to put those along, what I circled in blue is we're going to put those along the vertical axis. And what goes along the horizontal? Well, that's your length of the movies. So we want to see those. And so the lowest number is 80. So I'm just going to break the graph a little bit and start with 80 to 90, 90 to 100, to 110, to 120, 130, 140, and 150. So you label your horizontal axis. We see that we've got a maximum of 150, a minimum of 80. And so now, how do we find our increments along the vertical axis? Well, we see we've got as low as almost 4 hundredths. So we see 35 thousandths, so about almost 4 hundredths. And as high as, well, I see 25 hundredths. So why don't we just start at 5 hundredths and just go increments of 5 hundredths. And then from there, we build our histogram bars. So from 80 to 90, we saw that there was 1, and that was 35 thousandths. So just a real small bar there. 90 to 100, we saw that that was about almost 1500s, not quite. (100 to 120), we're almost from 100 to 110, excuse me, we were at about 2500s. So notice when I say 2500s, I'm just looking over here to make sure that I'm lining that up. From 110 to 120, where are we? We're at about 17, almost 1800s. (120 to 130), we were back at 2500s. (130 to 140), we were at almost 1100s. And then the 140 to 150, we were at 3500. So we should be pretty right there level with what we saw in the first one. I'll just color those in so you can see. Would be very symmetric if we had from that 110 to 120, if we saw that height come up to about right here, that would be very symmetric. We don't see that. The shape, there looks to be about two different modes, about here and here, which we saw show up at 2500s. It's pretty symmetric. We do see two modes, and most movies are between 100 and 130. So that's kind of what we're seeing, is most of the movies are showing up in that range. All right, finally, we're going to look at box plots, also known as box and whisker plots, and then we will go ahead and work on how we can create those. And the thing about a box plot is what it's going to show. It never shows a mean, never shows an average. It doesn't really show, it's really hard to determine how many or a number of students that fall in the graph. But it does show 5 important pieces. It shows your minimum value, your maximum value, your quartiles, and your median. Lower quartile and upper quartile. So when you're thinking about quartiles, that's telling you that all of your data is cut into fourths. And it also means that 50% of your data is going to fall within your box plot, in the box. So if we're thinking about our box and whisker, there's your minimum, there's your maximum point, there's your median of the entire data set, which is right here. This is what we call Q3. This is what we call Q1. Here is 25% of the data. Here's another 25% of the data. So what's left over? Well, that would be the 50%. So 50% is going to be inside the box. And then you can review how to make that box plot. And then I'll also go over that again, but we should see something that looks like the two that I drew. All right, to save us with time, I have temperatures for the month of February, but I went ahead and listed them numerically from left to right so I can create this box plot. So what we're going to find is I need to know how many I have. I don't know how many so I have 28. So I have 28 values. So I have an even number, which means since I have an even number, your median value is not going to be obvious. It's going to be between two different numbers. So if I go ahead and count those, so if I look at 14, right here is going to be your middle number. So the median of the data set is going to be 22 and a half. It's between 22 and 23, as you see right there. Now, we have an even number, so I've got 14 to the left of 22 and a half, and I've got 14 to the right. So I'm going to need to count. So the 1, 2, 3, 4, 5, 6, 7. Right here is what we would call our Q1, and it is between 15 and 17, so it's 16. And then I want to do the same over here. So I'm not going to count. I'm going to start with 23. And so my next one would be between 29 and 30. And so Q3 would be 29 and a half. And so my whisker would go all the way out to 4. This whisker would go all the way out to 39. And there you see your box, and there's your median value. So the minimum is 4. The maximum is 39. The quartile 1, so the first 25%, is represented from 4 to 16. So 16 is our first quartile. Q2, or also known as your median, is at 22 and a half. And Q3, which is another median, and that's going to be at 29 and a half. So these are your medians of your data set. And then we also have another one. It's called your IQR, which is your interquartile range, which tells you the range of this 50% of the data. Well, that's just Q3, take away Q1. And in this case, should be, 29 and a half, take away 16. So that should be 13 and a half. Now it's decent range. It means the numbers are spread out decently for 50% of the data. If we look at another question, we could say, well, make a prediction about part of the United States that you think the city might be located. Well, 17 to 29 degrees is what we see as 50% of your data is from 17, 16 to 29 and a half. So we see that. And so that range of temperature, the month of February, could tell us it's probably the northern part of the United States. And then we would say that we did find a way to describe it. We were looking at the 5-number summary to describe the min, the max, the median, Q1 and Q3, and then we found the interquartile range as well. Okay, let's look at one more. This will be the last one of our part 1 video series for week 4. So we've got diameter in miles of the original 9 planets. So here we've got our planets versus and the diameter that's given. So we would want to, in order to create this number summary, we want to line these up in numerical order. So I would recommend you pause in the video and go ahead and writing these diameters from least to greatest. So it looks like that we would have Pluto being our lowest and Jupiter being our highest. So go ahead and take a moment, pause the video, and write those out from left to right, least to greatest. So we've got our 9 from least to greatest, and we could say that our minimum is the 1,428, and that minimum is Pluto. And since we have 8 or 9, we got 1, 2, 3, 4, 1, 2, 3, 4. We're going to see that the 7,926 is our median. Now, so here's your median. When you're trying to find the Q1 and Q3, you're not including the 7,926. You're actually looking at a median with those 4 and a median with these 4. So that's going to be somewhere between 3,030 and 4,217. Now that's a take a sum. You're finding the midpoint, so take a sum and divide it by 2. So 3,030 plus 4,217, you're going to get 7,247. When you divide that by 2, you're going to get the lower quartile, which would be 3,623 and a half. The median, we've already stated, that's 7,926. We're going to do the same with the upper quartile, and that's going to be somewhere in here. So that's adding 31,762 and 74,896 divided by 2. And that upper quartile should be 53,329. And there's your box. There's your median. Whisker goes out to here and to here. And so that would give you a picture of it. Now, in order to help make a good, I guess if you're going to try to classify the distribution of everything, just lining them up least to greatest doesn't really give us quite a bit of a scale. So I did draw the box plot, but I'm going to go with more of a scale in this case. And I'm going to go from 0 and with quarters. And I'm going to go all the way to 100,000. So what I did is I just gave us a number line from 0 to 100,000, and then I want to put my minimum and my 5-number summary on the scale so I kind of get a better look at what does this look like. Okay? Well, my minimum value is, well, this would be about 12,000, so we're looking at a minimum value somewhere around here. Now, the lower quartile is about 3,000, so we're looking at somewhere around here, so it's a very small whisker. And then our median, I'm just pulling the data from over here at this at our chart, and I didn't finish that. The maximum was 88,838, and then the interquartile range is taking these two and subtracting them. So you should get 49,705 and a half. That just means that 50% of the data has almost 50,000 mile range. So what was our median? It was 7,000. So now you're looking at somewhere around here. And then our Q3 was 53,329, so we're looking at somewhere over here, and then our maximum was about 88,000. So kind of get a picture of it now. This data distribution is what we would call skewed to the right, because the tail of the data is stretched to the right. That 88,000 is definitely Jupiter and Saturn really have skewed the diameter in this. We said we had about 50,000 range within 50% of our data. It was about 50,000 mile range. But this is what it would look like if we put it on a scale, as opposed to just writing the numbers out and looking at the box plot. So scale kind of gives you a more of a, is this symmetric, is this skewed type of idea. So that's all I have for this first part with concepts of data analysis. So we looked at grades 1 through 6, and then we'll pick up with week 5, where we'll look at grades 7 and 8.